Assalamu alaikum, grade 9. How are you today? Let's start in our lesson, the third lesson in unit 2, which is talking about radioactive elements and radioactivity. Before we start, you should remember that the nucleus of the atom contains protons and neutrons, and there are electrons revolve around the nucleus. Protons and neutrons have greater mass than the electrons. That's why the mass of the atom was concentrated inside the nucleus. There is a repulsion force occurs between the protons. Why? Because they have similar charge, positive charge, so they moving away from each other, and this is called the repulsion force. But why do protons still exist inside the nucleus and they do not move away from each other? Because there is another force which is called a binding force that overcomes this repulsion force. So regarding to the nuclear energy, we have two forces. Number one, repulsion force between protons, and binding force, and this binding force, it makes the components together inside the nucleus, and it overcomes the repulsion force that occurs between the protons. Okay, so again, nuclear binding forces, they are forces that are necessary to bind the nucleus components together and overcome the repulsive force. Okay, in 1996, Henry Becquerel discovered unseen rays from uranium, and by the way, uranium is a radioactive element that can penetrate solid objects. Here is the nucleus of the radioactive elements. It contains large number of neutrons, more than the number required for its stability. So the nucleus of the radioactive elements start to emit radiations. These radiations are alpha, beta, and gamma radiations. Okay, so again, when I'm asking you what do I mean by radioactive elements, they are unstable elements whose atoms nuclei contains number of neutrons more than the number required for its stability, so it has excess energy, and it starts to emit, as we said before, alpha, beta, and gamma radiations. Examples like radium, uranium, and cesium. Radioactive phenomenon, it is a spontaneous or automatic decay of the nuclei of radioactive elements that are present in nature in an attempt to achieve a more stable composition. Okay, let's start about the talking about artificial radioactivity. Sometimes we can control this radioactivity as we use it in safe uses, like generating electricity, for example. But sometimes we cannot control it, like when we make a nuclear bombs in military purposes. This is the peaceful uses of the nuclear energy. It used in a lot of fields, like medical field, that used in treatment and diagnosis of some tumors like cancer, agriculture field to eliminate pests and improve some plants, industrial fields to convert sand to silicon sheets, because sand is silicon oxide, so it converted into silicon, and I use silicon in manufacturing of computer devices and processors. Electrical generation field, when I heat in water to produce steam, and this steam I use it to operate turbines and generating electricity. Instead of using a normal fuel, we use a nuclear fuel for space exploration, and in drilling field we use it for petroleum and underground water exploration. This is regarding to the peaceful uses of the nuclear energy. Okay, let's talk about the harmful effect of the radiation, which is radiation pollution. It is an increase of the amount of radiation in the environment, but the radiation, maybe it's the natural radiation sources like natural radioactive materials found on the earth, or it comes from outer space like cosmic radiations. Okay, this is regarding to the natural radiation sources, found materials or the elements that found in the earth or comes out from the outer space. Here the artificial radiation sources, the explosion of nuclear bombs of countries do experiments for time to time, or nuclear reactors. But what are the effects of radioactive pollution?
Radioactive contamination may be the result of direct exposure to radioactive substances on the ground, on plants or in water, or through contact with contaminated meat or fish. Vegetables with large leaves like spinach, salad or leeks are highly sensitive to radioactive fallout. Those growing underground like onions or carrots are less exposed, but the soil's contamination will eventually affect them. Radioactive elements can work their way down into groundwater and pollute drinking water. A nuclear incident may cause particles to be released into the ocean. In several instances, authorities have been forced to ban fishing in the face of a possible risk of marine life contamination. Many radioactive elements have a very slow decay rate. It takes 30 years to halve the radioactivity of cesium-137, an isotope used in nuclear plants, upwards of 300 years to cut it by 1,000.